Welcome back to the TechMoto channel and the electronics playlist. Here's another video for you to hopefully make electronics pretty straightforward. We've done these videos for hobbyists so they can just get cracking without getting too involved in the electronic theory. We're going to be looking at potential dividers today, or voltage dividers. I'm not going to go into the nitty-gritty of how the electrons are flowing or what potential difference is. We're just going to show you how we're going to put components in a circuit to make something happen. And as we go through this, you'll see how valuable this is to you in your various designs. Now, interestingly, our circuit has a 9-volt battery, which I'm calling the voltage supply. Now that means that there's a 9-volt difference, potential difference between this point here and this point here. Secondly, we have two resistors in series which are joining the positive and the negative rails of our circuit together, and pay close attention to the fact that both of these resistors are the same value, 220 ohms. I've taken an output from the middle of these two resistors and I've taken it through a motor just to show you how this works and how valuable this might be to you, which will make perfect sense after we've done a simple calculation. Now the calculation for potential dividers is this: V out, which is what's coming out of the middle of these two resistors, equals voltage supply, which is our 9-volt battery over here, times R2, which we've said is down here, which is 220 ohms. And we're going to divide that and put it in brackets, so we do this bit first. R1, which is 220 ohms, plus R2, which we've said is 220 ohms. And that's it. That's the calculation. So let's work through it. So V out equals voltage supply times R2 divided by R1 plus R2, so R1 is 220 plus 220, so that's 440. Let's go through it again. V out, let's add in all the values this time, so we've got 9 volts times 220 ohms divided by 440, and then if we carry on going down this route, we've got 9 times 220, which is, what is that, 1980. Divided by 440, which means that V out equals 4.5 volts. So potential difference between this point here is 9 volts, and the potential difference between here and here is 4.5 volts. Now, if you've ever used a DC motor in a circuit before, you'll know that if you put 9 volts through something, it's going to go at a certain speed. If you cut that voltage in half, that's going to slow down. And this is why this potential divider or voltage divider is a useful circuit to use. Okay, let's change it up slightly and let's change one of these resistor values. So we're going to change R2 to double that, 440 ohms. And let's see what happens if we do the same calculation. So we go back to my text tool here and we'll put in our V out equals voltage supply times R2 divided by, and in brackets again, R1 plus R2, close bracket. Okay, so if we work through it, V out equals, and we'll just do this really quickly this time, 9 times 440 divided by, what's that, 660. And if we process that one step further, 9 times 440 is 3960 divided by 660, which means that our V out equals 6 volts. So you can see that by changing the value of this bottom resistor here, we have changed the potential difference between this point here and this point here to 6 volts, again changing the speed of the motor. So in that original example we had 9 volts and we had 4.5 volts, and by changing the value of this resistor we've actually increased the potential difference between this point and this point. If we swap those two resistors around and we put the 440 in R1 and the 220 in the R2, I've just thrown the calculation up here to save a little bit of time. Same calculation, 9 times 220, because R2 is now 220. This is 440 times 220 because we've got the 440 up here instead. So V out is 1980 divided by 660, which gives us 3 volts. So by putting the 440 up here, a greater resistance for R1 and a lower resistance for R2, we're actually reducing the potential difference between these 2 points. So you can see from all these examples that just by varying these 2 values here and here, you can get any potential difference you want here to power whatever you have over here. What's really important is that if you have the same value here and here, it doesn't matter what value that is. If that was a 10k and that was a 10k, you'd still end up with 4.5 volts. If that was a 5k and that was a 5k, you'd still end up with 4.5 volts. It doesn't really matter what the resistance is here and here, but it's the relationship between these 2 resistors that makes the difference. Okay, so how does this work on a breadboard if you wanted to make up an actual circuit? So I've thrown a breadboard in here, we've got our 2 resistors, we've got our motor, and we've got our 9-volt battery. I'm going to throw my positive power to my red line here along my breadboard, which is my positive power rail. I'm going to take my negative to the blue line down here, which is my negative power rail. So as you've seen in a previous video, those holes are all connected together. So now they're all positive and they are all negative. We take our resistors and we just drop them into our breadboard here and here. Now these horizontal lines here go down to here and they stop here. We're going to take our motor and we're going to attach our motor to that point there, and we'll take the other half down to the negative line. And then we just need to connect that one to there. Now that's it. That's your potential divider all wired up in exactly the same way as it was shown in the circuit diagram in the last part of the video. So we've got positive coming through here. It's going through our resistors in series down to the negative, and we're pulling our different potential difference to our motor and back down to the negative. So dependent on the value of these resistors, that's a 220, that's a 220, that is currently getting 4.5 volts. And if we change the value of these resistors, we can change the speed of the motor. And there you go, that's it, potential dividers in a very short space of time. If you like this video, please do like and subscribe. Please do share it with others. If you like the software that I'm using here, it's a free piece of software from a company called Fritzing, and it allows you to make up breadboards and circuit schematics and PCBs and all sorts of other things. So, you know, go on, download it, have a go. As I say, it's free and it's well worthwhile. I'll catch up with you next one.